Hey YouTube, gonna make a quick video here for a friend of mine on how to polar align an older style fork mount telescope and give a quick little kind of how to on using setting circles, how to set them and use them. First off, without the telescope mounted to the wedge, what we'd want to do is loosen these two screws here and two on the other side, and set the tilt plate to your latitude. This is something that can be found with a quick Google search. In my case, it's latitude 41 degrees. You just loosen these up, up or down. There's a scale here in degrees and a little hash mark on here. You just get it as close as you can. You'll be making final adjustments when you actually go to polar align the scope. If you don't have a tilt plate that rotates, like mine, it doesn't rotate, set your tripod base and try to get that as close to north as you possibly can. In order to polar align, you have to have a good straight shot at Polaris. So getting this as close as you can to north, using a compass maybe, or however, even just eyeball. But the closer you can get it to north, the more it'll help you out when you actually go to polar align. Probably the most important step in this would be getting your tripod level. I can't stress it enough. Level is key here. You can polar align even if the tripod was tilted a little bit, but when you slew around to start looking at objects in the south, if you're not perfectly level, as you swing around, it just throws you way off, and it's gonna make it a lot more difficult to find objects and keeping them in the field of view as you're tracking them across the sky. So again, in my little carry bag, I have like an 8-inch carpenter's level. I'll put that up here on east and west, north and south, and adjust my tripod accordingly to get as level as I possibly can. If you don't have adjustable legs, you'll just have to figure out a way to get level. Mine did not have adjustable legs at first, but I kind of built my own. And so now it's just a matter of putting my level up here and adjusting a leg or two up or down to get as level as I possibly can. Once those first three steps are done, you can go ahead and mount the scope to the tilt plate here, and we can get ready to polar align. The next step would be we need to zero out the forks. The fork base, we need to zero out the fork base, the RA setting circle, we got to zero all that out. I know you can't see it, but I have a RA setting circle down here, and it starts at 0, and each hash mark on there is a 5-minute increment with a longer hash mark at, like, say 15 minutes, and then 20, 25, and then a longer hash mark for 30 minutes, and then 35, 40, and then a longer hash mark, so on and so forth, until you hit the first hour, and then all the way around your setting circle until you get to 23 hours, and then the final hour, which takes you back to 0. Basically, it's a 24-hour span, or 360 degrees, but we want to zero this out. So on my drive base here, I have a white little hash mark. That's my initial indicator. I want to rotate my setting circle so 0 is perfectly centered on that right there. So now I don't know if you'll be able to see it, but on my drive base, I also have an indicator that has a 0 reference on it, and it actually has a plus and minus. So if you want to try to deal in minutes and stuff and get a little more technical there. And I want to zero out my fork base to the 0 on the setting circle here. So I want that perfectly zeroed. And then my setting circle is 0 to the hash mark on the drive base. Should make a nice straight line. Lock your RA in position so that don't move after that. One note on the setting circle is you have numbers on the bottom and numbers up on the top. I don't know if 100% if I'm right here, but I think the numbers on the bottom is they count opposite to the numbers that are up on the top. So I'm assuming that if you're in the southern hemisphere, there's an adjustment you can do inside this drive base to make the RA motor run in backwards or reverse. And I would think since it runs in reverse, then the setting circle numbers that are farthest out, which normally count down, would then count up, if that makes any sense. So we're going to use the numbers that are closest to the fork base as they count up as right ascension turns and tracks the stars. Okay, so let's zero out our fork to 0 on the setting circle, and 0 on the setting circle is on the hash mark on my drive base. Okay, so now what we want to do is, this is a lot easier if you have a diagonal. You want to take your diagonal and turn this thing and push it 180 degrees so it's facing straight down, and I'll show you why here in a second. Once that's facing down, we want to loosen our declination clamp and rotate the head unit, the tube assembly. And what we're looking for here is we're looking for a perfectly straight line with tube and fork. We want that as straight as we possibly can get it. All right. So once you get that as straight as you can, if you want to try to get technical and get some levels or however you want to do that, lock that down. This is my declination circle here. Polaris sits at, you want to set this setting circle at plus 90 degrees. Polaris isn't quite plus 90 degrees. It's actually plus 89 degrees and some change. But getting this to plus 90 degrees will be close enough to where anything that you use to find with your setting circles, it'll be pretty much right there in the field of view. And then rotating your diagonal upside down. Now when you're actually flipped upside down, now it makes it right side up. So now we're ready to polar align the scope. We're locked in declination, we're locked in right ascension, everything's zeroed out. We're at plus 90 degrees. Now we can get ready. All right, so polar aligning, basically we stick a wider field of view, not too high of a magnification eyepiece in here. Let's say like a 25 millimeter with a decent wide field of view. If you're pretty close to north and your latitude is set pretty close, when you look in the eyepiece, you should be able to see Polaris. If not, you might have to, the reason I like a right angle finder scope here is because I can loosen that up and tilt that, and now I can use my right angle finder scope to help me zero in on Polaris. I have two finder scopes. I have the right angle that I bought aftermarket, and I have a 6x30 straight scope that came with the scope. My plan is I'm going to replace this 6x30 with a Telrad, and then use my Telrad in conjunction with my right angle finder scope to star hop and find my objects. But I'm not going to get rid of this straight finder scope. I'm actually going to mount it here on the bottom side of my scope, and it's solely going to be used for polar alignment. It'll be down and out of the way. I'll never have to use it until I go to polar align. But it'll make it a lot easier because then I'll be able to help use my straight through finder scope to aid in polar alignment. My right ascension zeroed out here, so I do not want to move it. Okay. If I look inside my eyepiece and let's say Polaris is too far south, it's down too far, and let's say I'm too far to the east. Well, I don't want to adjust my fine-tuned declination knob to try to get it in the field of view, and I definitely don't want to move my right ascension. What I do want to do, let's say number one, it's too far to the east, so my scope would have to turn just a little bit to the east to get that in the center line of the field of view of my eyepiece. Well, if you don't have the rotating tilt plate, what you're going to have to do is actually move the tripod itself. So what I would do then is I would look through here and just basically kind of, you know, bump my tripod until I can get Polaris to where it's in a straight line. But I still might be off north and south, okay? But once I get Polaris in that center line of the field of view of the eyepiece, now I can move on to fine-tuning the declination. If I'm looking in there, let's say Polaris is too low, so that means the scope would have to come up a little bit. This is where it can get a little tricky. So you're going to have to loosen your tilt plate screws on both sides, but you have to be real careful because as soon as you do that, with the weight of the scope, especially in this position, it's going to want to drop like a stone. You know, I was able to do it by myself out in the dark in the field, but and it took a few, you know, quite a few attempts. But you know, having a friend to help you out and kind of support the scope while you loosen this, and then he can, you know, up or down as you need it, and then retighten it. I actually made a couple of brackets and a piece of all thread, and made my own fine-tune adjustment for latitude here. It just makes it so I can do it by myself and basically hands-free, and then I can look through the eyepiece and just with a wrench, you know, adjust it as needed to go up or down until I can get Polaris directly in the center of the field of view of my eyepiece. Once you obtain that, you're done. You're polar aligned. Granted, you know, you're going to be properly north because you moved your tripod to obtain north, and granted you're perfectly level. You're in a straight line here, your declination plus 90 degrees, your right ascension zeroed out. You know, you look through here, Polaris is in the center of the view, perfect, you're done. You're properly polar aligned. Okay, moving on to setting your RA setting circles and using your setting circles to find your objects. Okay, number one, we're still zeroed out here. We haven't moved it, but we can go ahead and loosen the RA adjustment knob. In order to set your setting circle, you need to know the coordinates of a known bright star. And what I mean by that, I kind of wrote these down. I got these out of a book. I don't know if I'm going to pronounce this right, but Altair or Altair, we're going to call it Altair. Altair is right ascension 19 hours, 50 minutes and 47 seconds. But we're going to round that off to an even 19 hours and 51 minutes. Declination is 8 degrees, plus 8 degrees, and 52 minutes and 6 seconds. My setting circles ain't that accurate, so we're not going to worry about the minutes and the seconds here, except for we're going to round this off and say, you know, that's pretty, you know, for every basically hour of minutes and seconds is going to equal 1 degree of declination. So since we're pretty close to, you know, the next hour, we're going to round that off and we're just going to say it's plus 0.9. And maybe we'll just back it off just a little bit. So first off, when we want to set up setting circles, we have to find that known bright star. According to my planisphere, let's see, September 9th at 10 o'clock tonight, Altair is going to be south and a little bit west and pretty high in the sky. So what we're going to want to do is we're going to want to loosen our declination here, and we know this was our plus 90, and then it goes all the way to 0, and then anything below this is going to be minus. So you would have like plus 90, plus 80, plus 70, 60, all the way down to 0, and then we're going to go minus 10, minus 20, minus 30, and so on and so forth. So, but for us, we're going to call declination plus 9 degrees. So we're going to come up here, and we're going to put it about 9, maybe just a smidget under, and we're going to lock that into place. Okay. Next thing we want to do is we want to manually put Altair in the scope. All right. So with right ascension, we want to be able to rotate this over, and we want to use our finder scopes or what have you. But we want to find Altair, just a known bright star, something that you know for sure that that's what I'm looking at. That's the star that I'm looking at, real bright. And so you have the proper coordinates. So I'm going to use my finders, and I'm going to get out here so it's dead center of the field of view in my eyepiece here. As soon as I get that star in my field of view here, I'm going to lock right ascension. I'm going to start my right ascension motor drive. Now, with everything perfectly level and properly polar aligned, it's going to track that star as it tracks across the sky. So now we want to set our RA setting circle. So what we do is we know out here the coordinates for right ascension is 19 hours, and we're going to call it 51 minutes. So down here on our fork, where we have our little zero mark here, we're going to want to rotate our right ascension setting circle until we get to that 19 hours and 51 minutes. So let's just go to where it's 19 hours and 30 minutes, and then the next big hash mark would be 19 hours and 45 minutes. Each hash mark is 5 minutes, so the next hash mark is going to be 19 hours and 50 minutes, and then just give it just a tiny bit, and we're going to call that good. So it's basically set now. And as long as I don't turn the drive base off at any time, it's always going to track and move at the rate stars track across the sky. I think it's a sidereal or surreal or something. There's a name for it. But I mean, your right ascension circle tracks at the rate stars track across the sky. So even if I were to loosen my right ascension and say I spend the next hour just kind of playing around, and the whole time I'm doing that and looking for other things, as long as I don't turn the drive base off, this is going to still track at the same time stars track across the sky. So let's say an hour goes past. Well, in that hour, Altair actually went from over here, now it's down a little closer to the horizon, and it's a little farther west because as it goes across the meridian, or whatever you call it. But to go back to that star is basically, since I never turn the drive base off, and my setting circle clocks at a rate of what the stars are moving, as long as I put my declination back at the 0.9 degrees or close to it, and then I just rotate and line up my 19 hours and 51 minutes, presto, now I'm over here. It's a little bit farther over. As my clock drive would rotate, that rotates along with it. So that's an easy way to get right back to where you were. And as long as you, like I say, as long as you don't turn the unit off to where the stars keep on going, but your RA setting circle doesn't keep going, then you're going to have to align your setting circle. If you were to turn it off and walk away for an hour and come back, don't expect it to be where you wanted it. So now to use setting circles is pretty easy. I don't know the actual altitude or declination for, let's just take M31, the Andromeda Galaxy. It's over in the, usually at the beginning of the night, it's over in the east, and it's a little over by Cassiopeia, and let's just say it's like a declination 31 degrees. So what I would want to do is basically set my declination to, let's say, 31 degrees, and that's just a guess. But and then I know it's right ascension. It's like 0 hours and 47 minutes or something like that, and some seconds. But we're just going to say 0 hours and 47 minutes. So since I never shut my drive base off, I can just use my little hash mark down here on my fork, and then rotate this around until, okay, there's 0. All right, 15 minutes, 30 minutes, 45 minutes, and then just a little bit more. Presto, lock my RA. When I look in here, if I'm using a wider, like say 30 millimeter or 40 millimeter eyepiece with a good wide field of view, it should be pretty close to center of field of view. If not, it might be off to the side a little bit because you're not perfect in your calculations here, but it'll be close enough to where presto, right there's there's Andromeda. or say the Dumbbell Nebula, or the Ring Nebula, or over here the Whirlpool Galaxy. Or everything's got a declination and right ascension. So it's just a matter of getting your first initial star set to the your setting circle set to a known bright star, and as soon as you get that set, it's a piece of cake. It's just a matter of looking at your setting circles and your declination, and and like I say, it's pretty easy. I'm actually glad that my first scope that I bought was not a fancy go-to where these new scopes today, they don't even have setting circles on them. They rely solely on the computer to do all the work for you. Some people like that because, well, you might do get a little bit more observing time, but if anything were to happen to the electronics of that, good luck, because it doesn't even have setting circles. Without mine being a go-to scope, I was basically forced to learn how to use these circles. I take a certain pride and satisfaction, and when I get polar aligned and I use my setting circles, and according to the book, Andromeda should be 31 degrees and 31 degrees declination and 0 hours and 47 minutes, or 0 hours, 47 minutes right ascension. Well, it's just a matter of slewing this around, looking at my setting circles, and wow, look at that, it's right there. I think it does a lot better in teaching an amateur, the night sky. I definitely have one up on somebody that doesn't know how to use them. But I'm not knocking the go-tos. They are definitely easier. I just don't like the fact that a lot of these newer ones today don't even have setting circles. So, like, if something were to happen to the electronics or something like that, you might as well be on an old turd like that where it's just point and pray. Like you hope you can find what you want to look for. So hopefully this video can help you out. Like I say, I don't know if the polar alignment and even the setting circles is the proper way, but it works for me. If anyone out there knows of an easier way, or if they see something I was maybe doing wrong, I'm open for constructive criticism. So just let me know what you think in the comments. If you like the video, just give me a like maybe, or I'm not a like junkie, so I don't really care. But basically just made the video to show a friend. When I first started learning how to use these setting circles and basically polar align, I made a lot of mistakes, so this guy, I can tell he's not a total beginner, he's not an amateur, but when the first time you get an older scope like this, it can be, a learning experience. So I just wanted to make this video for my buddy Dale out in California. Hopefully this will help you out. I know it's kind of long. And I have to give a shout out to my friend in Manchester. His name's Andrew Carroll. He's an internet friend I met, and he's been like an absolute teacher to me. He's basically taught me almost everything I know here, and he's really helped me out in working through these backwards and things I've been doing wrong. He actually explained to me how the setting circles work, how to use them, how to set them, polar alignment. He walked me through that. So I can't take credit for any of this. I have to give credit to my buddy Andrew. He's just one of them old timers that he's been around the block and he knows his stuff. So he told me one day he passes on this knowledge to me in hopes that someday I can pass the knowledge on to somebody else in need. So again, I just made this video for my friend, but I'm probably going to post this on YouTube. So if maybe it can help out a beginner or somebody who's picked up an older type scope that has never really done manual setting circles to find your objects, or even polar alignment, hopefully, and maybe you can walk away with something from this. So I appreciate you watching, and like I said, I hope this helps you out. So hope you enjoy.